ಆಯ್ತಾ? Good morning. Yesterday we were discussing about different types of diseases, right? Bacterial diseases, for example, tuberculosis, cholera, typhoid, etc. Right? In one examination, they have asked which among the following disease can be transferred or transfused with the help of blood transfusion? Means which disease can spread through blood transfusion? Which cannot spread through blood transfusion? Actually, the three diseases can spread through blood transfusion. One cannot. HIV is the virus name, right? The disease name is AIDS. Human immunodeficiency virus causes acquired immunodeficiency syndrome. Acquired immunodeficiency syndrome. What are the symptoms? Body's immunity is reduced, very much reduced, so that even the small, simple diseases might turn fatal. That is the problem. Immunity reduces here. Acquired immunodeficiency syndrome. AIDS disease can be diagnosed with the help of a special test called as ELISA. Very important. We'll discuss in detail while discussing about biotechnology. ELISA, enzyme linked immunosorbent assay. Enzyme linked immunosorbent assay, major test to detect HIV AIDS, that is blood test itself, the name ELISA. Then even RT-PCR test can detect HIV. Reverse transcriptase polymerase chain reaction test. Polymerase chain reaction test. RT-PCR. Then Western blotting technique can also be used to detect HIV. Well, HIV virus spread through blood transfusion. 100% yes. It does spread through blood transfusion. Then hepatitis B. Do you know which organ of our body this disease affect? Majorly liver, right? Largest gland of our body. Liver is affected by hepatitis B. This is also a viral disease, hepatitis B. Then malaria is caused due to, generally when we hear about malaria, the first thing comes to our mind is mosquito. But it is a vector-borne disease, means the disease spreads through mosquito. The disease causing agent, it is Plasmodium vivax. Plasmodium vivax protozoa. Protozoans are generally unicellular, few are multicellular, and protozoans have nucleus, eukaryotes. Example for protozoa: amoeba, euglena, paramecium. In our school days, you might have drawn the diagram of paramecium, then euglena, right? Amoeba. Those are protozoans. Malaria protozoan disease caused by the protozoa called Plasmodium vivax. The disease spreads through mosquito. Female Anopheles mosquito, malaria. Then a typhoid, Salmonella typhi, Salmonella typhi, typhoid. The disease mainly spreads through contaminated food and contaminated water. Typhoid, contaminated food and water. Salmonella typhi, the bacteria. Typhoid disease can be detected with the help of a blood test called as Vidal test. In one examination, they asked about typhoid and they have given different statements. Does typhoid spread through blood transfusion? No, the statement is wrong. Then whether it is a bacterial disease or viral disease. Which disease? Bacterial disease, Salmonella typhi bacteria. Then test to detect typhoid, Vidal test to detect typhoid. Typhoid disease does not spread through blood transfusion. Malaria can spread if the same syringe is used or blood transfusion happens. Then there are chances. Hepatitis B, HIV, 100% they will be transfused with the help of blood. Typhoid, vector-borne disease. Sorry, contaminated food and water. Vector-borne diseases. Vector-borne diseases means the disease which spreads through vectors. Vector means carriers, right? For example, filaria, filariasis. Have you heard the name? They have planned to eradicate filariasis by 2017, extended to 19, extended to 20, extended to 22. They're continuously extending the dates. If in case anything in news regarding filariasis, they might ask, filariasis is caused by roundworm, roundworm called filarial worm. Filarial worm. See, do you know about pinworm, hookworm, tapeworm, liver fluke disease? No? ಜಂತುಹುಳು ಕೇಳಿದಿರಲ್ವಾ? Similarly, these are parasites which enter human body and take nutrition from us, and they will start to reproduce in the host in the human body. Filariasis disease, you will be knowing, but not the name. Filariasis is also called as elephantiasis. Elephantiasis. Have you heard the name? Hathi pond disease, Anakalu roga. The deceased person's leg will be swollen like a elephant's leg. That's why the name elephantiasis, filariasis. This filarial worm is spreads with the help of mosquito. Mosquito. Vector-borne disease. Vector-borne disease, filariasis, elephantiasis. Parasitic worm, parasite, filarial worm, parasite causes the disease. Roundworm. Then malaria caused by Plasmodium vivax protozoa. Plasmodium vivax protozoa. Vector, mosquito. Female Anopheles mosquito. Malaria, vector-borne disease, protozoan disease. Then very important, Japanese encephalitis. Have you heard the name encephalitis? No. Have you heard the news few years back? in Yogi Adityanath's constituency, Gorakhpur, Uttar Pradesh. In Gorakhpur Medical College Hospital, nearly 60-70 children died due to unknown reason. Later, after so many research study, they got to know the children died due to encephalitis. Encephalitis is a viral disease. Generally in Kannada, we call medalu jwara, right? Encephalitis. Japanese encephalitis is a type of encephalitis caused by Japanese encephalitis virus. This viral disease. See, around the brain, we have fluid, cerebrospinal fluid, and we have a layer that swells, and the swelling of brain causes this issue. Japanese encephalitis. Vector mosquito, Culex mosquito. Culex mosquito spreads Japanese encephalitis, vector-borne disease. Then we have dengue. Dengue viral or bacterial disease? Viral disease. Dengue. Dengue is caused by the same named virus, dengue virus. Dengue virus. Vector Aedes aegypti mosquito. Aedes aegypti mosquito vector. Generally, this type of mosquitoes breeds in sewage water, but Aedes aegypti generally breeds in fresh water. During the time of monsoon, you might have heard the garbage collecting vans announcing, don't keep any coconut shells, etc. Water might accumulate, then mosquitoes might breed, and it will help for the dengue to spread. Right? Dengue, Aedes aegypti. These are some important vector-borne disease. Will HIV spread through mosquito bite or any insect bite, blood-sucking insect bite? No, not possible. Yes. Right. Then we have endemic diseases, epidemic, then pandemic. Endo, inside, small, okay. Endoscopy, right? Endemic means the disease is confined to smaller geographical area. For example, a district, few districts, that's it. Not even a state, right? This is called as endemic. The best example for endemic disease is KFD. Have you heard the name KFD? No. Have you heard the name? No. Casanova forest disease. Every year this will be in news. Okay. Casanova forest disease, very important disease which we must know. KFD. Casanova is a village in the district of Shimoga. What happened there? Actually, there are so many bacterial viral diseases which still we haven't got. For example, corona. Corona was there with the bats probably from ages. When human came in contact with that bat, the disease spread, right? Likewise, in the forest region of Casanoro, there is a special monkey fever. Monkey fever, Casanoro forest disease, where The monkeys affected by this virus, Casanova forest virus, monkeys affected by this virus, they generally gets infected and dies. Then the ticks, blood sucking insects which bite on the monkeys, and then if they bite the humans, then the disease spreads. When human invaded the forest, went inside the forest, when he comes in contact with the monkey which infected by monkey fever, then the disease spread. It is limited to that region only, KFD, Casanova region. That's why the name Casanova forest disease. National Institute of Virology Pune developed a vaccine few years back, but that didn't give fruitful results for KFD. Endemic, restricted to some smaller geographical area, the disease. Then we have pandemic. Generally, in Canada, we say Sankramika Roga, the disease which spreads rapidly, right? Epidemic, coronavirus, the disease is generally called as COVID-19 because coronavirus in December 2019, right? In December 2019, the disease outbreak happened in China. Then in 2020 March, World Health Organization announced the COVID-19 as a pandemic. Earlier, it was an epidemic till March 2020. In March 2020, they announced it as a pandemic. Epidemic means it is affecting more geographical area than an endemic disease. For example, many are districts of a state or many states of a country. Let's say many states or many districts are more people. This is epidemic, and which is spreading fast. Epidemic. Okay. When it crosses the boundaries of the countries, when it spreads to many countries, when it spreads to many countries, and controlling it becomes nearly impossible. That condition, it will be called as a pandemic. Generally, the cholera, dengue, etc., these kind of diseases are considered as epidemics, right? Pandemic, corona, pandemic. Earlier, plague was a pandemic, smallpox was a pandemic. Likewise, corona was the recent pandemic which we had. Pandemic. Worldwide reach it is having. Okay. Let us start with physics. They will not ask any formulas, derivations, problems to solve. They might ask application based questions. Like, for example, in one of state PSC, Karnataka state PSC examination, preliminary examination, they have asked this question. A body is moving in a circular path. An object is moving in the circular path. Okay, circular path. The force which is acting on the body is away from the center. The force acting on it is away from the center. Then this kind of force which is acting away from the center is called as centrifugal force. Centrifugal force. While moving in a curve, you feel, if you are in higher speed, you feel like moving away from the center curve, right? You might fall off. That is due to centrifugal force. Then planets or satellites revolving around Earth. Satellites revolving around Earth. The force of attraction is towards the center. This is called as centripetal force. Centripetal force towards the center. This is away from the center. Centrifugal force. When a bike is moving in a circular path or corner, it tends to move away from the center. That is due to centrifugal force. Okay. Then your washing machine at your home, how does it work? There will be so many holes inside the drum. When the machine starts to rotate rapidly, water, the detergent, then the dirt mixed together will move away from the center, right? The holes will be opened, then it moves away from the center. This is centrifugal force away from the center, centrifugal force. Towards the center, centripetal force. In this examination, they have asked a biker, a biker, assume this as a bike. Okay. A biker moving in a curve bends his body towards the center. He bends the bike towards the center, right? Towards the curvature, right? To attain necessary dash force, they have asked. A biker moving in the curve bends the bike towards the center to attain necessary dash force. Centrifugal or centripetal. Generally, when the bike is moving in the circular path or curved path, what kind of force will be acting majorly? Centrifugal force away from the center. To balance that force, if he goes straight, then what happens? He might fall off. He might go like this, right? That's why he is bending his bike to gain the necessary centripetal force, balancing. A car moving in a circular path. A car moving in a circular path falls off. A car moving in a circular path falls off from the curb. They have asked in a SSC examination which wheels leaves the ground first. They have asked which wheels, means not the front back. Inner wheel or outer wheel? Inner wheel means the wheels which are towards this center, this part, inner wheel. Then these are outer wheels. Outer wheels. Which wheels leaves the ground first? Just imagine you are going in a curved path, right? Curved path. The car falls like this, right? Then which wheels are leaving the ground first? Inner wheels, right? This is inside of the circle. This is outside of the circle, right? These wheels leaves the ground first and the vehicle falls off. It flips. They might ask these kind of questions. They have asked in many central government and state PSC examinations, right? We should be having some basic understanding. International System of Units, SI units. See, earlier in many different civilizations, they used different type of measurements to measure different physical quantities, right? For example, we used feet, then inches, yard, etc. to measure the distance. Right now, we are using to measure the distance meter, kilometer, centimeter, right? SI unit of distance length is meter. Okay. Under international system of units, see, we all have considered France's France metric system of measurement. metric system of measurement as SI units. There was a convention called a Meta Convention. 70 plus countries, leaders around the world participated, and they decided in the 1790s that from now onwards, France's metric system of measurement will be the international standards of measurement, right? For example, average human body temperature is 37 degrees Celsius. We generally use degrees Celsius, right? Boiling point of water, 100 degrees Celsius. Freezing point of water, 0 degrees Celsius. But SI unit of temperature is not Celsius, Kelvin, SI unit of temperature. Likewise, there are fundamental units of measurement, fundamental, that cannot be derived from any other physical quantities. Then we have under SI units, then we have derived units. Derived units. Derived unit means speed is equals to distance by time, velocity is equals to displacement by time, force is equals to mass into acceleration, weight is equals to mass into acceleration due to gravity, right? These are derived units. Speed is derived from distance and time, force derived from mass and acceleration. These are derived units. We have, very much important, only 7 fundamental units of measurement. How much? Only 7 fundamental units of measurement. Other than these 7, all are derived units. Okay. What are the fundamental units of measurement? Means fundamental units of measurement. Mass. Do you know the difference between weight and mass? Okay. See, consider this object. It might be having many molecules, right? It is made up of, let's say, 9 molecules. This object is made up of 9 molecules. The same object we carry to moon, the same object we carry to Mars. Will the number of molecules present in that object vary? No, the same number of 9 molecules will be there. What will happen? The weight of the object varies because weight is equals to mass into acceleration due to gravity. Acceleration due to gravity in Earth is 9.81 meter per second square. In Moon, it is 1/6 of Earth's gravity. It is very less. That's why, for example, the first person to land on Moon, the first person to land on Moon, American, Neil Armstrong. Okay. For example, the weight of Neil Armstrong was 70 kgs. 60 kgs, let's say. 60 kgs. Okay. His mass on Earth and his mass on Moon both will be the same. The mass will not vary. What will vary? Weight will vary. It is 60 kgs here. It will be 10 kgs on the Moon. Only 1/6, 10 kgs on the Moon, right? Weight is a derived quantity. Mass is fundamental quantity. Mass is the measure of body's inertia. Mass. SI unit of mass is kilogram kg. SI unit of mass kg. But what we generally do, we use SI unit of weight as kg. Weight. We do measure weight in gram, kilogram, etc. Right? But SI unit of weight is Newton. SI unit is Newton, but we use kg. We use kg. Kg is not the SI unit of weight. SI unit of mass is kilogram kg. Then SI unit of temperature. Temperature is the measure of body's hotness or coldness. Temperature. SI unit of temperature is Kelvin. SI unit of electric current. Electric current SI unit. Ampere. It is measured with the help of ammeter, ampere, electric current. Then assign it of time. Time assign it seconds. Seconds assign it of time. Then SI unit of distance. Distance, length, width, breadth, height, depth, everything's SI unit is meter. Meter. Then we have luminous intensity. Luminous intensity means the amount intensity of light coming from a luminous object. Luminous object means which gives out a light. For example, light bulb, luminous object, sun, luminous object, stars, luminous object. Luminous intensity. Earlier in our house, we had incandescent bulb, right? Filament type bulb. Filament type bulb, right? What we used to ask at the shop to purchase a filament type bulb? How many? 60 candle. Do you remember? Or what? You haven't purchased any bulb? Okay. Generally, people used to say 60 candle, 100 candle, 150, 200 candle. Like, it is not candle, it is candela. Luminous intensity is SI, it is candela. Candela. Then, amount of a substance. Amount of a substance. How many molecules are there in that substance? How many molecules are there? Amount of a substance. SI unit is mole. Mole. These seven are the fundamental units of measurement. SI unit of mass kilogram, SI unit of temperature Kelvin, SI unit of electric current ampere, time seconds, distance meter, luminous distance meter, luminous intensity candela, amount of a substance mole. Seven fundamental units of measurement. Very basic important thing which we should know. Fundamental units of measurement. Then we have derived units. Derived units. SI unit of force, Newton. SI unit of speed, SI unit of velocity, meter per second, meter per second. SI unit of acceleration, acceleration, meter per second square, meter per second square, meter per second square. This can also be written like this, meter per second square, acceleration. Then SI unit of work, SI unit of energy, SI unit of heat, work, energy, heat. SI unit is joule. Kinetic energy, potential energy, SI unit is joule. Joule. Then SI unit of density, density, mass per volume, density, mass per volume, kg per meter cube, kg per meter cube, mass per volume, density. Electric potential difference, electric potential difference SN it is volt, measured with the help of voltmeter, potential difference volt. Electrical resistance SN it is OHM, ohm. The symbol is like this, ohm. Electrical resistance. Electrical conductance. Actually, earlier it was measured as MHO. Right now, Siemens. Siemens is used as the SI unit. Siemens. Electrical conductance. Siemens. We have considered a metric system of measurement as international system of units. We also have other systems of measurement MKS, CGS, FPS, systems of measurement. First one is distance. Second one is mass. Third one is time. In MKS system, SI unit of distance is meter. SI unit of mass is kilogram. SI unit of time is seconds. In CGS system, SI unit of distance is centimeter, gram, and seconds. In FPS system, foot, pound, and seconds. In an examination, they have asked in all these three systems, MKS, CGS, and FPS, which physical quantities SI unit is same? Which physical quantities SI unit is same? SI unit of time is same in all these three systems. SI unit of time in all these three systems, MKS, CGS, and FPS, SI unit of time is seconds. SI unit of time, seconds. Rarely they have asked about MLT formula. SI unit of speed is meter per second, right? SI unit of speed, meter per second. M means mass. L means length. T means time. Here, SI unit of speed is meter per second, right? Here, mass is 0, length is 1, time is -1. This is the MLT formula. Dimensions we say. Dimensional formula. Or dimensions of SI units. Mass, length, time, 3 dimensions. Here, if kg is there, means m will be +1. Kg is not there, so mass 0. Meter length is there, +1. Then 1/second is there, right? This can also be written like this, ms -1. So time -1. Now, acceleration SI unit, acceleration meter per second square, meter per second square. The MLT formula will be MLT, m power. Mass is not there, so m will be 0. Length is there, meter, so L will be 1. Then time is there, how much? 1/second square. If that comes to the, what will happen? Meter second, ms -2. So time will be -2. For density, SI unit is kg per meter cube. MLT, mass 1, length, time is not there, length -3. These are the dimensional formulas. You should know SI units. In examination, what they will do? The dimensional formula for density is, they will give the options. You should be knowing the SI unit. Later we can answer. Rarely they ask. In many central government examinations like SSC, RRB, etc., they will 100% ask. In UPSC, it's very rare. Then let's move on to the interesting chapter before that. Important measuring instruments, measuring instruments. To measure wind speed, anemometer is used. Anemo means wind. Anemometer to measure wind speed. Anemometer. What happened? Wind speed. Then atmospheric pressure. Atmospheric pressure is measured with the help of barometer. Very much important. In many examinations, they have asked application level questions on this barometer. Around our earth, we have atmosphere, right? The layers of the atmosphere: troposphere, stratosphere, mesosphere, thermosphere, exosphere. We have atmosphere. See, you are on the surface of the earth, mean sea level. Then you are above a mountain, Mount Everest. When compared to your position on the Mount Everest, then your position on the surface of the earth, where atmospheric pressure will be maximum, this position, A and B, where will be atmospheric pressure be maximum? Take a guess. Earth is having atmosphere because of gravitational force. Due to Earth's gravity, the air is around the earth. When you move away from the earth, when you are climbing a steep mountain, few thousand meters above the mean sea level, oxygen content will increase or decrease? Decrease, right? Means the gases are becoming rare, density becoming less, right? Where atmospheric pressure will be maximum? Indian women's cricket team won World Cup for the first time, right? And they are celebrating here. Smriti Mandana, here Harmanpreet Kaur. Who is feeling more pressure? One above another. Who will be feeling the pressure? The one at the bottom, right? Obviously, one above the other. If they are falling and celebrating, at the bottom the pressure will be more. Moving away from the bottom, the pressure will be less. Likewise, maximum atmospheric pressure will be near the surface of the earth, right? When you move away from the earth, atmospheric pressure decreases. They have asked by giving statements. When you are taking barometer on top of Mount Everest, the barometer reading will decrease or increase. Atmospheric pressure on the top of Mount Everest will be less when compared to Bangalore here on the surface of Earth. So atmospheric pressure will decrease. Hence, barometer reading will decrease. Right? It will decrease. When you go into a underground mine, when you go deep into a underground mine, in KGF movie he went, right? Underground mine, then barometer reading will increase because the air above you, the quantity of air above you will increase. The scuba divers use special swimsuit, then oxygen cylinders, then also in very rare cases, many dies due to brain injury. Have you heard? Because when you go deep under the water, the amount of water above your body increases, right? That water applies pressure on your body. If you go very deep into the sea without any proper suit, your bones might break. For example, if you have time, there is a movie called Ghazi Attack. Many years back it came, Ghazi Attack. There was an unofficial war between Pakistan and India. Pakistan with a second-hand submarine gifted by America. They tried to capture our Vishakhapatnam region. That was destroyed with our second line submarine. Submarine will be having a range. A range to operate means 300 feet below the sea level, 500 feet below the sea level. If it goes still deeper, the submarine surface will start to bend. It might blast. That amount of pressure will be exerted by water. When you go deep into the earth's surface or water, the atmospheric pressure will increase. When you go away, pressure will decrease. Barometer they have asked, if the barometer reading is going down slowly, it is going down slowly. What does it indicate? Barometer reading going down slowly indicate here in this area atmospheric pressure is decreasing. Atmospheric pressure is decreasing. If low pressure is created here, what will happen? Air from the region of high pressure, wind from the region of high pressure starts to move towards this direction, from higher pressure to lower pressure region. Then if barometer reading is going down slowly, it indicates a rainfall. It indicates rainfall. If barometer reading going down rapidly, going down rapidly, it indicates on the surface of earth, it indicates thunderstorm. Thunderstorm. Near the ocean, it indicates cyclone. low pressure area is created. Extreme low pressure area is created due to rapid decrease in the barometer reading atmospheric pressure. Hence, thunderstorm, cyclone happens. If it goes down slowly, rainfall happens. Rainfall happens. Barometer. Then to measure humidity. Humidity means the moisture content present in the air around us. There is a moisture content in the air around us, less humidity. When you go to the coastal region, humidity will be high. Humidity is measured with the help of psychrometer. Psychrometer. Relative humidity. Relative humidity is measured with the help of relative humidity measured with the help of hygrometer. Hygrometer. Relative humidity. A relative measurement means measuring it against any standard quantity with a reference quantity, a relative humidity, hygrometer. Then blood pressure BP measured with the help of sphygmomanometer. Sphygmomanometer BP. Average human blood pressure is average human blood pressure 120 bar 80 millimeter of mercury, 120 bar 80 mm of Hg, 120 systolic pressure, 80 diastolic pressure. Fluid density measured with the help of hydrometer. Then altitude or height of the object is measured with the help of altimeter. Then various kinds of meters are there. Then have you heard about a radar? Radar. During the time of standoff between India and Pakistan, which happened recently after the Pulwama attack, not Pulwama attack, which attack happened recently? Pulwama earlier attack, right? Okay. After the recent attack, there was a standoff. Even Pakistan and India both launched many missile systems to both the countries' regions. But Indian air defense system tackled the enemy attack successfully by destroying the missile in the air itself. When Pakistan launched a missile, Indian radar detected the missile at what speed, at what distance it is coming. Then it will launch a defense missile. It will go and intersect the missile in the air itself and it will destroy the missile. Not even a single missile came and attacked us on the land. Each and every missile were intercepted in the air itself. Radar means radio detection and ranging. Radio waves are used here. Radio detection and ranging. Radio detection and ranging. Radar. Radar systems are used in the defense field to detect enemy aerial vehicles like helicopter, drone, missiles, etc. And the radars are also used in our air traffic control station in our airport. ATC will be there, right? Here, radar is used to detect incoming and outgoing flights. Then sonar, sound navigation and ranging. Sound navigation and ranging sonar. Here, ultrasonic sound, generally ultrasonic sound is used. Ultrasonic sound. Sonar is generally used for navigation in the ships and submarines. In the ships and submarines. To detect any object under the sea or for navigation, sonar system is used. In air, radio waves. In water, sound waves are used. Okay. Sound, form of energy. How sound is formed? By the vibration of particles. While you speak, you can feel the vibration. When air is passing through this hole, our voice box, called as larynx, the membrane vibrates. Due to the vibration, sound is produced. Sound needs medium to travel. Sound needs medium required. Sound cannot travel in vacuum. Can light travel in vacuum? From sun to the earth, there is no medium present. There is vacuum. Sun. We do get sunlight, solar heat in the form of radiation, right? That is, light can travel through vacuum. Light travels faster in vacuum actually when compared to water, glass, etc. But sound cannot travel through vacuum. Sound needs medium. Sound needs medium. How sound is formed? By the vibration of this particle. By the vibration of this particle, it transmits the energy to the adjacent particle. It vibrates. It transmits the energy. Likewise, by the vibration of particles, sound is traveled. If the particles are at a far distance, then sound travels slowly. If the particles are closely packed, then sound travels faster. Right? If you are sitting here, a person sits there, a girl sits here. Difficult to communicate, right? If a person sits beside you, you can easily talk, easily communicate. Likewise, sound travels in a medium with less density. Let's say sound travels slower in air compared to water, compared to steel or any solid object. Sound travels fastest in air, water, steel. If they ask steel, if you keep your ear on the desk and if you tap from beneath, you will hear more sound, right? Instead of doing this, you will hear more sound because sound travels fastest in solid objects. Sound requires medium. Sound requires medium. How light travels in a straight line, right? Light travels in straight line. Sound travels like a wave. Sound wave. What kind of wave? Longitudinal wave. Sound wave is a longitudinal wave. Longitudinal wave. Longitudinal means when a person is speaking here, it is parallel to the surface of the source. Parallel to the surface of source. Longitudinal wave. Sound wave. The mean baseline. The successive distance between two crest or trough is called as wavelength. This is wavelength. Wavelength. Wavelength symbol lambda. Lambda. Wavelength symbol lambda. Then see, this is wave A. This is wave B. Which one is having more wavelength? Not more number of wavelength. Wavelength means the distance between this point and this point. Two successive trough, crest, right? So wavelength is more in A, right? The distance between these two successive crest. Frequency means how many number of times the particle vibrate in a second. How many number of time the particle vibrates in a second. If frequency is more means wavelength will be less. Here the frequency is more, here the wavelength is more. Wavelength and frequency both are inversely proportional. Inversely proportional. Then you might have used a few voice recording applications. If you start to speak slow, it will be recording like this. If you speak at a louder voice, it will go like this, right? Loudness, loudness or louder voice is dependent on a feature called amplitude of sound wave. Amplitude will be higher, means the wave height of the particles vibration will be more. If loudness is more, amplitude will be higher. It will be higher. Then pitch. In many singing competitions, you might have heard pitch. Pitch of sound. Pitch is related to the vibration, the frequency, not the loudness. The frequency, the vibration. When compared to pitch of a male voice and a female voice, pitch of means the vibration, the depth. Pitch of female voice is higher compared to pitch of male voice, not the loudness. The pitch, the vibration, the depth is more in female voice when compared to male voice. Then SI unit of sound. Sound is measured in the recent have you seen the final match between India and South Africa, right? When India won, when Harmanpreet Kaur took the catch, there beside Rohit Sharma's face, it was showing the sound meter, right? 127 dB, decibels. Okay, SI unit of sound is decibels. From 0 decibel we can hear, from 0 decibel when there is no noise, even we can hear the rustling of leaves, somebody whispering, an insect making a sound, right? We can hear from 0 decibel. Whispering 30 decibel. Normal conversation 50 to 60 decibel. Normal conversation 50 to 60 decibel. Above 80 to 100 decibel and above is considered as noise. This is considered as noise. If you hear louder, noisier sounds for longer duration of time, then your hearing ability will be reduced. Noise more than 100 decibels, we can say. Then very much important thing, human audible range. Human audible range means how much frequency ranges sound which we can hear. The frequency range which we can hear. See, have you heard about ultrasound scanning machine? Ultrasound scanning machine. To check any abnormality in any internal part of our body, generally all ultrasound scanning is done. Will the machine make any loud, big noise which we can hear? No, we cannot hear any sound, but actually it is making noise. It is making sound. The frequency range is not in our audible frequency range. It is higher than that. Human audible range is 20 hertz frequency to 20 kilohertz frequency range. 20 kilohertz means 20,000 hertz. 20 kilohertz. This is human audible range. We can only hear frequencies from 20 hertz to 20 kilohertz. Below 20 hertz we cannot hear. Above 20 kilohertz we cannot hear. Below 20 kilohertz it is called as Infrasonic sound, infrasonic sound. About 20 kilohertz, it is called as ultrasonic sound, ultrasonic sound. Bat, bawli, bat. It navigates with the help of ultrasonic sound. Bats are nocturnal animals, right? Nocturnal means active during night time, right? God is the greatest creator. He planned humans and other organisms will be sleeping during the night time. Bat will be using sound to detect their prey and for navigation. It might be disturbing for other organisms. So he planned what? Let bats use ultrasonic sound for navigation, which we cannot hear, ultrasonic sound they're making for navigation. And dolphin use ultrasonic sound for navigation. Do you know in are dolphins present in freshwater? Freshwater, like yes, in India we have freshwater dolphins. For example, Indian national marine animal, Indian national water animal, that is Gangetic dolphin. Gangetic dolphin, very much important. Gangetic dolphin. In ecology, you will study, you must know Gangetic dolphin. In many preliminary and mains examination, they have asked a question about Gangetic dolphin. The main thing is Gangetic dolphin is blind. It does not have any eyes. It does not have eyes. This Gangetic dolphin finds its prey and navigates only with the help of ultrasound. Only with the help of ultrasound. It can't see. Gangetic dolphin. National water animal, marine animal, Gangetic dolphin. Okay. Even dogs can hear ultrasound. Elephants can hear infrasonic sound. Rhinos can hear infrasonic sound. That's why what we think, oh, dogs can see ghosts. That's why it is standing there and looking, barking at something. What is happening means they can hear the sound which we cannot hear, the ultrasonic sound. Dogs and other animals. The frequency range of their hearing ability is different. Then echo from the source, sound wave is traveling and reaches a surface. It bounces back. Sound bounces back. This is called as reflection of sound. Due to the reflection of sound, due to the reflection of sound, the echo is formed. Echo is formed. During the time of echo, we hear two sounds, right? Hello, hello, hello. We hear twice, right? The time gap between the original sound and echoed sound is 0.1 second. 0.1 second, the time gap. 0.1 second, echo time gap. Echo is due to reflection of sound. Actually, even echo can be formed here if there are no furniture, if every surface is plain, no curtains, windows, then echo can be formed, right? But for echo to be formed in its purest form, the distance between source and surface should be 17.2 meter. For echo to be formed in its better form, the distance between source and surface should be 17.2 meters, 17.2 meter. That is the reason in Gol Gumbaz you can hear that much precise, well defined echo. Can sound travel through water? Sound travels fastest when compared to air in water, then fastest in steel, right? Sound travels in water. Next time, if you go swimming inside the water, try tapping two stones. You can hear more sound when compared to outside in the air. Sound travels fastest in water. We cannot speak, that's why we don't know. But it travels fastest in water because the molecules are closely packed. Closely packed. In one examination mock test, they have asked if there is a bomb blast on the surface of moon. If there is a bomb blast on the surface of moon, after how much time we can hear the blast sound? After how much time we can hear the blast sound? They have given 10 minutes, 5.2 seconds, 3 minutes. No, we cannot hear. There is a bomb blast on the surface of the moon. After how much time we can hear? We cannot hear because moon does not have any atmosphere. No atmosphere is present. Will sound travel in vacuum? No, sound requires medium, right? That's why sound cannot be heard. Sound cannot be heard. Okay. Light, a unit of luminous intensity. Candela, 7 fundamental units of measurement. Candela, a unit of luminous intensity. Luminous intensity. Okay. Light travels in straight line. Light travels in straight line. Straight line. Actually, there are so many theories. One scientist tells light travels in straight line. Other person comes and tells no, light is a particle. It travels like a particle, photon particle. And other person comes and tells that no, light is like a wave. It travels like a wave. But now let us consider light travels in straight line. Travels in straight line. We can hear a person talking outside because sound does not travel in straight line. It travels like a wave, vibration of particle, medium we can hear. But can we see the light coming out from the laptop outside? No, because light travels in a straight line and it will not travel through opaque object. Opaque object. Light travels through transparent object. We can see through transparent object. Opaque, it will not. Translucent object means somewhat quantity of light passes, but we cannot see clearly through it. We cannot see clearly through it. Translucent object, translucent object. Here, this instrument is called as periscope. Periscope. Two mirrors are placed in 45-degree angle. 45-degree. 45-degree angle. Two plane mirrors are placed here. When we see from here, and a person seeing from here can see the object placed here. A person inside the submarine, to see the objects outside, he can use this instrument called as periscope. Periscope. From inside the submarine to see the objects outside, periscope is used. What happens here? Light traveling in this direction is reflected and travels here. With the help of this reflection, a person standing here can see the object here. Periscope. To see around the corner, to see from the submarine. This instrument can be used, works on the principle of reflection of light, basic reflection of light. Two plane mirrors are used here. Plane mirrors are used here. A reflection of light. A reflection. There are two types of reflection. One is light is being reflected from this surface also, right? It is being reflected from the floor also, right? But we cannot see our image. We cannot see our image on this object, not even on the floor. But if there is a plane mirror, we can see our image, right? Reflection, light travels in straight line, travels in straight line. When parallel beams of light strikes a surface and bounces back parallelly, this kind of reflection is called as a regular reflection. A regular reflection. When parallel rays of light strikes a surface and bounces back in different direction, this is called as irregular reflection. Irregular. On this surface, on the floor, irregular reflection is happening. That's why we can see little glow but not the image being formed. Okay, where the image is formed only in the regular reflection, the image is formed only during regular reflection. Reflection means light ray striking the surface and bouncing back. Reflection, bouncing back. Law of reflection. This is the plane surface. Light ray coming and hitting this surface. This is called as incident ray. Incident ray. Then this light ray is reflected. This is called as a reflected ray. Then for our reference, at this point we have drawn a perpendicular line called normal perpendicular line. Why we have drawn the perpendicular line? To calculate the angle of incidence and to calculate the angle of reflection. See, in the case of regular reflection means parallel rays comes and goes in parallel direction itself, right? Angle of incidence will be equal to angle of reflection in each and every possible case. For example, see, if light beam coming like this, it goes out like this, angle of incidence will be equal to angle of reflection. Law of reflection. Law of reflection. Then a refraction. Before that, plane mirror. You have seen the mirror. In the mirror, image is being formed, right? Image is formed. We have discussed about this during the discussion about eye topic, right? We have discussed. Yes. A person standing in front of the mirror, his image is formed behind the mirror. If person comes near the mirror, the image will also come near the mirror. If he goes away, the image will also move away. If the image is formed on the surface, it is called as a real image. If the image is formed anywhere behind the surface, it is called as virtual image. In the plane mirror, virtual image is formed. In the plane mirror, virtual image is formed and erect image is formed. Erect. You are standing upright. your image is also standing upright. Erect image is formed. Then, if you are standing in front of the mirror having food from your right hand, it appears as if you are having from left hand, right? This is lateral inversion. Lateral lateral inversion is seen. What type of image is formed in a plane mirror? Virtual, erect. Laterally inverted image is formed. Virtual, erect, and laterally inverted image is formed. The image is formed due to the phenomena called reflection of light. Then we have refraction. Light travels through vacuum. Yes, vacuum. Will it travel? Yes, the sunlight reaches Earth through vacuum. Light travels through vacuum. Light travels through air, 100% S. Glass, S. Water, S. Diamond, S. Transparent medium. Light travels through transparent medium. But the density of these mediums will be different, right? Density of vacuum, air, glass, diamond will be different. When the density of the mediums are different, light traveling in straight line will bend. The bending of light is called as refraction. Okay, take a break for 5 minutes. We'll continue. Okay. A refraction of light means bending of light when it travels from one medium to another. Diffraction. Here, let's say it is traveling from water to air. It is traveling from water to air. Water is denser medium. Air is a rarer medium. Normal imaginary perpendicular line. Normal imaginary perpendicular line. When light travels from air to water, when it travels from air to water, the light ray bend towards the normal. This normal bend towards the normal. When you are running on a hard surface, you will be running fast. When you are running in water, your speed slows down, right? Same thing. When traveling from air to water, it bend towards the normal, bending towards the normal, towards the normal. From rarer medium to water denser medium. Here, if light travels from denser medium to rarer medium, it will bend away from the normal. It will bend away from the normal, away from the normal. Here, angle of incidence is more than angle of refraction. Angle of incidence is more than angle of refraction. Here, angle of incidence is less, angle of refraction is more. Angle of refraction is more. The bending of light is refraction, bending of light. There is a law called Snell's law, law of refraction, Snell's law, Snell's law. N1, N2, theta 1, theta 2. Simply, N1 sine theta 1 is equals to N2 sine theta 2. Snell's law. That means the bending of light, which we have discussed, from denser to rarer medium, away from the normal, from rarer to denser medium towards normal, that only it will explain. Here, N1 and N2 are refractive index values. Refractive index. Refractive index means when compared to vacuum, the speed of light reduces by what value? When compared to light, the speed of light reduces by 1.3, 1.5. Likewise, a refractive index of light in vacuum is 1. Reference value. Refractive index in vacuum, it is 1. A refractive index in air, it is 1.0003, or approximately 1, we can say, air. Then a refractive index of water, it is 1.33, water. Glass, it is 1.5. Refractive index of diamond, it is 2.42. A refractive index of diamond, 2.42. Okay. In many exams like SSC, RRB, state PSCs, they will ask the refractive index values, like match the following. They will give air, water, glass, diamond, etc., and they give the values. You need to match, or you should be knowing which one is having higher or lower refractive index values. Application of a refraction or a refraction effects. Refraction effects. in a glass of water, in a glass of water, if you place a coin, if you place a coin, the coin appears to, the coin appears to raise a bit, raise a little bit, or when you place a pen, a pen inside the water, it appears to bend, it appears to bend. That is due to a refraction, the bending of pen, then coin moving upward, or depth of a pool appears to be less. That is due to a refraction. The swimming pool's depth is this much. When filled with water, when filled with water, the base of the swimming pool, base of the swimming pool appears to be raised. The depth, we feel like it is less deeper, but actually it is more deeper. This illusion is due to refraction. This illusion of coin moving upwards is due to a refraction of light, a refraction. The pond appears less deep due to, they will ask, that is due to refraction. Pond appears less deep due to. Then in one examination they have asked, SSC examination, a fisherman standing on the bank, fisherman standing on the bank trying to catch a fish. He is seeing the fish here, right? He is trying to catch the fish with the help of a spear. With the help of a spear, he is trying to catch that fish. The question is where he should aim to catch the fish. Should he aim directly into the fish, or should he aim directly into the fish, option A, or above the fish, option B, below the fish, option C, in front of the fish, option D they have given. Where should he aim to catch the fish? They have asked. This is phenomenon of refraction. See, you have a container filled with water. A container filled with water. Due to refraction, it appears to be, the bottom appears to be raised a little bit. The bottom, see, when you see from one angle, the bottom, it's actually here, appears to be raised a little bit, right? Or when you place a pen, it appears to bend, right? That is due to refraction. Actual bottom is here, but it is visible here. Likewise, there. Likewise, there. Actual fish is here. Actual fish is here, but it appears to be raised in the water. Where he should aim? He should aim below the fish. He should aim below the fish to get the fish due to a refraction. A refraction. Then twinkle, twinkle, little star. You have heard, you know. You are standing on the surface of the earth. You are standing on the surface of the earth and watching the star twinkle. Do the stars really twinkle? Do the stars have their own light? Yes. For example, sun. Sun is a star. They emit their own light. Color of star is due to temperature. If temperature is more, the color will be blue. If the temperature is medium, the color will be yellow, like our sun. If the temperature is low, means the color will be red. The color of the star is dependent on temperature. Here, the twinkling of star. twinkling of star. That is due to a refraction. How? Our Earth's atmosphere density is different, right? Near the surface, the density is more. When we move away from the surface, the density is less. When light enters the atmosphere of the Earth, it travels through different densities air. Hence, the refraction happens. Due to the refraction, stars appears to twinkle. Twinkling of star is an optical illusion. Twinkling of star is an optical illusion. It is not happening actually. That is due to refraction of light. That is due to a refraction of light. Then there is a big illusion which we haven't observed. Have you seen sunrise, sunset properly? Sunrise, sunset. From the horizon, the sun starts to rise, comes above, then sun starts to set. Actually, the position of sun is here. Let's say at 5 a.m. the position of sun is here. Okay, but it is appeared to be here. Sun appears to be here. Why? When you place coin into a glass filled with water, the coin appears to be raised due to refraction, right? Refraction. Likewise, in the atmosphere, sun appears to be raised a little bit. Same thing. Sun is actually here right now. It already set, but it appears to be still here. This is due to refraction of light. We can see sunrise, we can see sunset, even though sun is not at this position, it is actually at this position, right? This is also illusion. This illusion will be there for 2 minutes. 2 minute early sunrise, 2 minute late sunset is due to 2 minutes early sunrise, 2 minutes late sunset is due to refraction. This is illusion. The first 2 minutes of sunrise which you are seeing is not the actual sun, it is an illusion. Last 2 minutes of sunset which we are seeing is not the actual sun, it is illusion due to a refraction, of light, right? A refraction. Then we have total internal reflection. Total internal reflection, TIR. Total internal reflection. Let's say water, air. Which is the denser medium? Water, denser medium. Lesser denser, a rarer medium, air, a rarer medium. Total internal reflection means when there are two transparent medium, water, air, water, glass, air, glass, etc. Two transparent medium, light can pass through them, right? From air to glass, water to glass, it can travel. During that time, what will happen? When light travel from one medium to another, it will bend. The bending of light is called as a refraction of light, right? But here, total internal reflection or internal reflection means the light will not travel to the other medium, it will bend inside the medium itself, it will reflect inside the medium. That is internal reflection. See, first condition for total internal reflection is light source should be in the denser medium. Light must travel from denser medium to rarer medium. First condition, light is traveling from denser to rarer medium. A refraction is happening, a refraction away from the normal, it is bending, right? Then light traveling from denser to rarer medium. During this time, if angle of incidence is greater than critical angle theta c, critical angle will be different for different densities water. Water density will be very different, right? Hard water, soft water, fresh water, like theta c, there is no standard angle like 45 30, no standard angle. If angle of incidence is more than critical angle, then what happens? The light bends in the same medium. Light will not go away, it will bend in the same medium. In water itself, the light starts to bend. This is called as internal reflection. Internal reflection. If complete rays of light are reflecting internally, then total internal reflection. If fewer rays are reflecting internally, multiple internal reflection. Total internal reflection. For total internal reflection to happen, there are two conditions. First condition, light should travel from denser medium to rarer medium. First condition. Second condition, angle of incidence should be greater than critical angle. Angle of incidence should be greater than critical angle theta c. Then only total internal reflection can happen. Total internal reflection applications, phenomena. First one is mirage. Have you seen during the time of summer on the tar road, it appears to be water present on the surface? Have you seen on the tar road during peak summer, water appears to be on the surface of the road, but when you move forward, there is no water. It's an illusion. That is called as mirage. Mirage. Mirage is due to total internal reflection. Mirage can be seen on the surface of tar road as well as in the desert. Mirage, optical illusion due to total internal reflection. Mirage. Here, the denser and rarer medium will be air itself. Denser air, rarer air. Then, sparkling of diamond. Sparkling of diamond. Sparkling of diamond. That is also due to total internal reflection. Sparkling of diamond, total internal reflection means diamond denser medium, air rarer medium. Light is entering from air to diamond. From air to diamond, light is entering. Is there any chance of total internal reflection? First condition is light should travel from denser medium to rarer medium, right? So it is not possible here. From air to diamond, it is not possible. Now, from diamond to air, it is possible, right? When light is trying to move out from the diamond, it is possible. Diamond to air. Here, what happens? The light reflects inside the diamond itself. Inside the diamond, the light starts to reflect. This reflection causes sparkling kind of effect. The sparkle of diamond is due to total internal reflection, TIR, total internal reflection, optical phenomena. This is not an illusion, this is reflection, TIR. Then endoscope, instrument. Endoscope you have heard, right? They will put a pipe like a structure with a camera at the end inside your internal parts, stomach maybe, or other parts also, right? The wire used here is optical fiber cable. Optical fiber cable. In the optical fiber cable, in the optical fiber cable, what happens? Communication. It is used in communication, right? Communication. Data travel in the form of light. Data travels in the form of light. Here, optical fiber cable is used. Optical fiber cable is used. This is not exactly optical fiber cable. This is LAN cable. Here, there are so many small fibers are there, right? Those are glass fibers. That is transparent. Within that, light travels internal with the help of internal reflection. Optical fiber cable is used in the endoscope. Optical fiber cable works on the principle of total internal reflection. Optical fiber cable works on the principle of total internal reflection. Hence, we can say endoscope instrument also uses TIR, total internal reflection. Optical fiber cable discovered by an Indian origin scientist called Narinder Singh Kapani. Narinder Singh Kapani, father of optical fiber cable, Narinder Singh Kapani. These are all the uses of total internal reflection. One mirage is formed, mirage, then optical fiber cable we use, endoscope we use. Then sparkling of diamond is due to total internal reflection. Sparkling of diamond, total internal reflection. Plane mirror, one side is transparent, one side is opaque. The back side of the mirror through which we cannot see, it is painted, right? What is used? Which kind of paint? Do we paint with a normal paint? Can image be mirror be formed? No, right? The special kind of a reflecting surface is used. Special kind of a reflecting surface coating is used. That is silver powder, silver nitrate, silver compounds, silver powder. Let's say silver powder is used in the reflecting surface in a plane mirror. Plane mirror. Plane mirror is used for a reflection. Then we have two different important type of mirrors called convex mirror and concave mirror. Curved inwards, hollow, shallow, cave, right? Concave mirror. This is flexed outwards, convex mirror. Convex mirror. When light falls on the surface of convex mirror, when light falls on the surface of convex mirror, will it move outward or will it move inward? It will move outward. It will move like this. This is called as diverging mirror. Diverging mirror. Diverging mirror. Here, when light falls on the surface, it will bend inward and meet at a point. It will meet at a point. Principal focus at a focal point. It will meet light. This is called as converging mirror. Converging mirror. Converging mirror. Applications of these two mirrors are applications where we will use these two mirrors. Concave mirror. In plane mirror, the size of the image formed will be enlarged, diminished, or of the same size. If we see ourselves in a full-sized mirror, the size of the image formed will be same as ours, or it is bigger or smaller? Same, right? In the plane mirror, the image formed is of the same size of the object. But here in the concave mirror, enlarged image is formed. Enlarged image. Enlarged image is formed in the concave mirror. The smaller objects are seen bigger here. Concave mirror majorly used by dentist. Have you been to any dentist? The dentist will use a spoon-like structure. At the end, there is a circular shaped mirror. It feels like a steel only, not exactly the mirror. By placing it inside our mouth, he can see each and every corner of our teeth, gums, etc. Right? The mirror used by the dentist is concave mirror, curved inwards. The reason, he wants to see the enlarged image of our teeth. Enlarged image. To get the enlarged image, the dentist is using a concave mirror. Then ear, nose, throat, specialist doctors use, ENT specialist doctors use concave mirror. Then inside the torch, a vehicle. See, a torch. Inside the torch, the reflecting surface will be like this, right? Bulb is here, the reflecting surface. The shape of this reflecting surface is concave. Inside a vehicle's headlight, inside a vehicle's headlight, curved inwards. This is concave. Vehicle's headlight, torch, the reflecting surface, they are using concave mirror. Then in solar furnace, have you seen the solar furnace? Hmm? Have you seen? No. See, this is the solar furnace. Here, the mirror used is curved inwards. Curved inwards. This is which mirror? Concave. Concave mirror, right? Concave mirror is a converging mirror or diverging mirror? Converging. Light rays come, converge and meet at a point. Here what happens? The light falling on this mirror is converged and falls to this single point where the cooking utensil is placed. Then the food inside is cooked. Solar furnace uses concave mirror. Solar furnace, free of cost cooking, but takes time. needs proper angle. Okay. Solar furnace, concave mirror is used, concave. Then shaving mirror, generally Generally, we use a normal plain mirror, the smaller in size for shaving, right? But there is a special mirror called shaving mirror where concave mirror is used because to give enlarged image. If you get an enlarged image, it will be easier. That's why shaving mirror. Then convex mirror, vehicles rear view mirror, vehicles rear view mirror. In your bike, this much sized rear view mirror is there. From this small rear view mirror you can see the bus, lorry, car coming behind you, right? The complete full sized vehicle can be seen. That means the bigger vehicle is diminished and you can see the object clearly, right? Which kind of image is formed is diminished image is formed here. Diminished image, smaller image, diminished image, and you can see more area, right? The road, sky, trees, vehicles, right? More area can be covered. Wider field of view, diminished image is formed, and wider field of view, much larger area is covered with the help of convex mirror used in vehicles rear view mirror. In a few vehicles rear view mirror, you might have seen they have placed one more small mirror here in few cars. Reason to see more area. That's it. The curvature will be very high. In mirror, what we feel it is just like a flat plane surface mirror, but actually it is convex mirror, vehicles rear view mirror. Then we have security mirror or traffic signal mirror. You might have seen this special mirror with a red hat in parking lot entrances, DMAT, etc. You might have seen. This is convex mirror. Reason for using this mirror is it gives wider field of view. A person coming from this direction can see person coming from the other direction, right? In the traffic junctions, in the intersections, especially this mirror is used. Traffic junctions. Then at the security entrance gate, for the security person to observe both outside and inside objects, this is used. Security mirror, convex mirror. Then vehicles rear view mirror is convex mirror. Vehicles rear view mirror. Traffic signal security mirror. Application important. Then lens. What is the main difference between lens and mirror? We can see through the lens. We can see us with the help of a mirror. In mirror, image is formed. In lens, we will get the view, right? This is a piece of glass. This is not called as a lens. Lens should be either bulged outward or bulged inwards, curved inwards. Both the surfaces curved outwards, then here curved inwards. Which type of lens is this? Concave means shallow, hollow, curved inward. This is bulged outward, right? This is convex lens. Convex lens. This is curved inwards. This is concave lens. Concave lens. Convex lens. Concave lens. Here, have you made fire with the help of magnifier? You haven't burnt your friend's skin. No? Try once. Magnifier. When light passes through the convex lens, it bends inwards and meets at a point. It will converge. Converging lens, convex lens. Light rays are converged to a particular point, single focal point. By adjusting the sunlight to a single point, you can create fire on the paper, right, with the help of this magnifier lens or convex lens. Then concave lens, when light passes through a concave lens, it will bend outward. This is diverging lens. Diverging lens. You might have seen at least the magnifier, right? If you see any object letters through the magnifier, bigger view is formed or smaller view is formed. The object, will it be seen in a bigger size or smaller size? Bigger in size. Here, convex lens, enlarged view. Enlarged view, we will get enlarged view. Here in concave lens, we will get diminished view. Diminished view and wider field of coverage we get. Where exactly we use this kind of lens means this convex lens. If a person is suffering from hypermetropia, farsightedness, that can be corrected with the help of convex lens. If a person suffering from myopia, nearsight, that can be corrected with the help of concave lens. Then in microscope, you can see very small objects in a bigger size, right? That is convex lens. In magnifier lens used is convex lens. Then a concave lens, the door peephole lens. You can see more area, right? The person will be little small in size. That is this concave lens. Peephole lens. Then wide angle selfie camera lens. Wide angle camera lens. These are concave lens. Major applications. Majorly it is used to correct eye defects. Correct the eye defects. Lens. When white color light is made up of how many colors? White light is made up of 7 colors. Violet, indigo, blue, green, yellow, orange, red, vinegar. You know, right? White color light passes through a prism. When it passes through a prism, it will start to split. It will start to split. White color light is made up of 7 colors. 7 colors. Violet, then indigo, then blue, then green, then yellow, orange, then red, red, violet, indigo, blue, green, yellow, orange, red. Right, 7 colors. White light is made up of. When white light is passed through the prism, it will create a spectrum of light. Spectrum of light. This is called as dispersion of light. Dispersion of light means splitting of white light into 7 colors. Splitting of white light into 7 colors. 7 colors. Violet, right? Okay. Which light is bending more? Violet. Bending less? Red color light. Wavelength of red light is more. Wavelength of violet light is less. Red color light is having a longer wavelength. Longer wavelength. In the middle of the spectrum, we have green color. In the middle of the spectrum, the prominent colors which we see in the spectrum is here. In the top, we see red. In the middle, we see green. In the bottom, we see blue. This red, green, blue is called as primary colors. Primary colors. RGB, red, green, blue, primary colors. Right. In many examinations, they have asked why danger signals are always red. Traffic signal, vehicles, tail light, danger signal, always red. Why? The main reason is, see, from the direction of light, it is not bending that much, right? From the direction, it is not deflecting that much. Bending is very less, very minimal. A red color light used in danger signals because it is least deviated. It is least deviated. Then it is least scattered. Scattering is very less. Scattering means moving out in different directions. Least scattered. Least scattered. Then very important, it is having longer wavelength. It is having longer wavelength. It can travel longer distance. It can travel longer distance. Longer wavelength it is having. Red color light is used in danger signals because it is having longer wavelength. It is least deviated. It is least scattered. Very much important. Red color light. Then in the spectrum, the prominent colors are red, green, and blue. Red, green, blue, right? Blue color of the sky is due to Why? Sky is blue. It is blue. If in case, actually, space tourism is a booming field. Space tourism. Earlier, people went to pilgrimage trips. Later, people started to trips to beach, mountain, etc. Now, other countries. Later, during the time of our retirement, probably people will go to outer space, international space station, or other planets for trip. That will happen. Many space organizations already started space tourism in testing phase, right? If you go to the surface of the moon, on the moon, and if you see the sky around the moon, it seems in black color because there is no atmosphere in moon. There is no atmosphere. That's why it appears black. Space appears black. You might have seen, right, in many photos of astronauts doing spacewalk, etc. It appears black because there is no atmosphere. Here around our Earth, we have atmosphere, right? When sunlight enters the atmosphere, due to the presence of small dust particles, air, etc., what happens? The light starts to scatter. Scattering of light happens. Which color light will scatter more? Red, green, blue. Red is least scattered, right? Then most scattered will be obviously blue. Blue is most scattered. That's why sky appears blue. Sky appears blue due to scattering of light. Due to scattering of light, sky appears blue. Ocean appears blue. Sky appears blue due to scattering of light. When sun is here in the rising spot, here in the setting spot, sunlight needs to travel a longer distance, right? Sunlight needs to travel a longer distance. During this time, least scattered, longer wavelength, least deviated color is seen. During sunset and sunrise, you see, means the sky as well as sun appears reddish color. That is also due to scattering. But here it is due to less scattering. Here blue color is due to more scattering. That's all. In the daytime, sky appears blue due to more scattering. In sunrise and during sunrise and sunset time, sun appears red, sky appears red due to less scattering. Both the reason is scattering. Then interference of light, interference of light, and there is rain on the tar road. If there's an oil spill, oil appears in this color, right? Rainbow kind of color. This phenomenon of light is called as interference of light. Interference of light. Even soap bubble, even the soap bubble appears in that rainbow kind of color, right? That is also due to interference. Interference of light. Interference of light. Here what happens? The water is here. Oil is floating on the surface. Why oil is floating on the surface? Because when compared to density of water, density of oil is less. density of oil is less, it is floating on the surface. Here what happens, sir? The light falling on this surface reflects, some part of light reflects from top of the surface, some part will travel to the bottom and it will reflect back. Same light beam reflects twice, some part from the top, some part from the bottom. Then the overlapping of light happens. Here violet, indigo, blue, green, yellow, current, yellow colors overlap to form rainbow like appearance. This condition is called as interference of light, can be seen here during the oil spill on the rainy wet road, also in the soap bubble, even on the back surface of a CD, DVD, you can see the rainbow kind of color, right? That is due to interference of light, right? Then rainbow, generally, when is rainbow formed? During a cloudy, less light condition, or during bright light rain condition. When does rainbow form? Sunlight should be there, even rain should be there, then only rainbow can be formed. Even we can see rainbow while during the time of sprinkler irrigation in some farmlands, right? A rainbow is formed due to combination of many phenomena, not due to a single phenomena of light, due to a reflection of light, due to a refraction of light, due to total internal reflection, due to dispersion of light, due to dispersion of light. All these four phenomena combined, a rainbow is formed. By combining all these four phenomena, we'll discuss this tomorrow. Okay.